안녕하세요. Hello. Hello, hello, hello. I am back. Okay, it's working now. It's really silly. I've changed my audio setup, you know. I told you guys about that. And ever since then, I have to start OBS before starting... No, I have to start my DAW before starting my OBS. 아니, 저번에 오디오 셋업 바꿨다고 했잖아요. 그 이후로 항상 이제 OBS를 키기 전에 DAW를 켜야지. 안 키면은 오디오가 먼저 OBS를 킨 다음에 DAW를 키면은 소리가 안 넘어가. For some reason, the sound doesn't get sent properly to OBS if I turn on OBS before the DAW, which is very, 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 very silly. Now I know I'll make sure to turn on the DAW before I turn on the whatchamacallit? OBS. Anyway, today is a special stream featuring Zen 5. I don't have Zen 5 as a disclaimer. My opinions based on the reviews and an analysis that I read. So yeah, with the disclaimer out of the way, let's get started. 입술 소리? 입술 소리? 뭔 소리? Anyway, oh lord, Riel ranting while charging up the laser menacingly. Setsunafariha. Why must AMD be like this? Riel modding so hard we don't even have the animated loading screen. What liha? Tinklenim liha? AMD le bad. Setsunafa says audio. Yeah, audio, I explained that. OBS before DAW and it's bad times. I think it's because of the driver that I'm using is dependent on the DAW. It's a Reaper specific driver, so I think Reaper has to run before OBS. Or yeah, just not work. Doesn't work like that. Arisol's Alfariha, Riel's mouse is moving but no sound's coming out. She's sad mad. Audio is not needed to see Riel's rage. I am fuming right now. I am censoring all the Korean swear words. Maybe I was. Wait, I think I can read her mouth. I think she's saying next week we will be full Souls game exclusive. No, that's definitely not true. It has been 0 days since last NEA scuff. Yeah. Non-mecha Souls game. Oh, she also said Kag the Gomen cover next week was Reverse Bunny MV, not happening. And the week after next is all Rock and Stone, not happening either. Does she know? She knew. And she said Kerbal stream will be mandatory at least once a week. That is not true. Kerbal is dead forever. 커버는 진짜 영영 돌아오지 않습니다. 영원히 돌아오지 않습니다. Is it ticked on in OBS? Yeah, everything was set up correctly. It was just the order of starting the programs. OBS after Reaper. Don't worry, all NEA members can read your mind. She said from next week I'll stream every day. That is also not true. 커바를 석방하라 아닙니다. 커바는 죽었습니다, 영원히. Well, on the bright side, at least the scuff happens now instead of on the grand AC6 shebang tomorrow. Yeah, now I'll know for tomorrow I'll turn on Reaper before everything else. Honestly, I'm not sure if she's trying to say something or just eating Big Mac. I was not eating on company time. Alright, not company time, I mean. The organization's time. Is every time any time? It's any day, every day. 그래도 인텔보단 나으니까 좋았어. 물론 그거는 모르는 일입니다. 리뷰어들이 이번에 AMD 젠5 리뷰 샘플 받은 다음에 엄청난 문제들이 많았다고 해요. 뭐 메모리가 6000 메가 트랜스퍼에 안 켜진다. 구동이 안 된다. 뭐 성능이 들쑥날쑥이다. 기타 등등. But he trusted the information found on the internet. Clearly all audio issues would be fixed on Linux. No. 석방하라 석방하랍니다. Everything would work flawlessly on Temple OS. Nah. 783D 오너니까 좋았어. 아 진짜 783D 세일할 때 사는 게 사놨으면은 당신은 승리자입니다. 인생의 승리자는 아니겠지만 그냥 컴퓨터 하드웨어의 승리자입니다. 아니 아니겠지만이 아니고 일 수도 있고 아닐 수도 있지만 783D를 미리 샀으면은 당신은 컴퓨터 하드웨어의 승리자입니다. 네. 성능 구려봐. 잼퍼 쓰고 잼퍼 안고 죽으면 그만이야. 아니 내가 지금 걱정하는 게 AMD들 얘네들 AM5에 젠6 안 내는 거 아니야 이러다? 젠5 우려먹다가 아니 AM4에서 젠3 4년 동안 계속 냈거든요? 19년이었나? 젠3 처음 나온 게? 3000대 나오고 아니 5000대 나오고 20년이었나? 20년이었나 보다 5000대 나오고 무려 이번 달 6월에 6월이었나 7월이었나 5900XT랑 5800XT가 나왔잖아요. 4년 후에. 그러면서 얘네들 하는 말이 우리 아직도 AM4 CPU 만든다고 AM4 서포팅 계속 한다고 그러는 거잖아. 얘네 젠5 2027년에 내놓고선 이름 9955XT 뭐 이딴 식으로 내가지고 셀 CPU야 아직도 우리 AM5 서포트하고 있어. 하지만 벌써 AM6 내놨죠. 2025년에. 그러기만 해봐 진짜. 난 정말 많이 화낼 건. So yeah, one of the Korean viewers were saying, whatever, I'll just stick to my Zen 4, right? And now I'm just worried. Wait, on AM5, are they just gonna, or AMD just gonna, they say they're gonna support it through 2027 plus, was their wording, I believe. Now, they're claiming they're still supporting AM4 by releasing garbage CPUs like 5900 XT and 5800 XT. And they're like, oh yeah, we're still supporting releasing Zen 4 4 years later, or whatever. Or I mean Zen 3. Zen 3, 4 years later. So, you know, Zen 5 came out in 2024. They can technically release a Zen 5 in 2024 plus 4 years, so 2028, and say that they're still supporting AM5. And the chip will be like 9955 XT or some garbage like that. All the meanwhile, AM6 comes out in like 2025 or something. I'm gonna be so mad. I bet you buy X970 motherboards will see AM6 socket. I'm dying. Zen plus 5%, more like Zen plus 0.5%. No, I think it's fair to call it 5%. 르네상스 예술가 이름이 떨어져서 아, 르네상스 아니죠. 그리고 렘브란트는 그 뭐냐 그 다음 세대잖아. 아이고. 인상파 전. 르네상스 후 인상파 전. 어쨌든 간에 예술 역사 들은 지 좀 오래돼서 잘 기억은 안 나요. 어쨌든 간에 그건 중요한 게 아니고 we need ARM to get good. ARM is a Proton tier compatibility layer to x86 64. Yeah, the Qualcomm is bad. You know, even if Intel and AMD are Not doing well. Let's just put it like that. Not doing well. Qualcomm chips, they ain't it. They ain't it. Re-releasing chips and slapping a new coat of paint, single-digit gains, is just plain Intel shenanigans. Yeah. That's gonna be what AMD's 2027 Plus support is. There's a reason why they're not saying Zen 6 is supported. They're saying the socket is supported, not Zen 6. Well, conspiracy theories aside, let's talk about the actual products that are out there right now. NBA is getting high and having a genius moment like this. 코로나 때문에 연기되었다고 하죠. 터보나르 트림님이 어서오세요. 자, anyway, Zen 5, not AM5, Zen 5. Let's talk performance first. 일단 Zen 5 성능에 대해서 얘기해볼까요? So, as a reminder, this talk is from a point of view of a streamer. Gamer slash streamer. Slash, you know, I do Adobe stuff too. 일단은 그 스머로서의 그 입장이 대부분이에요. 제가 말하는 거는 스트리머, 게이머, 그리고 뭐 어도비나 뭐 이런 거 쓰는 사람의 관점입니다. 빅맥 리딤 죽었어. Fake buffer and wait, I think that's from yesterday. Zen 5 has no measurable gaming uplift whatsoever. Well, it's measurable. Barely. So let's take a look at some TPU graphs. tech power-ups. 일단 테크 파워 그래프를 먼저 보고 시작할까요? So we're gonna look at 9950X and 9700X. 자, 테크 파워업의 9700X 리뷰입니다. 와우. 하게 먹고 배경은 그냥 신경 쓰지 않으셔도 돼요. If I sat in front of you, say in front of a 7700X PC and a 9700X PC, if I sat you, then you could not tell the difference. Yeah, but things I could say that about a lot of chips. You could not tell the difference between a 5800X 3D and like, I don't know, 14700K. Probably even 14900K. You'd probably need at least like 2x difference. 진가는 3D가 나올 때 밝혀질 것이다. 그거에 대해서도 오늘 말할 겁니다. 그거에 대해서도 제가 할 말이 있습니다. And yes, I do have something to say about the X3D part as well. Predictions. Real predicts. We can come back to it. We can visit this video in 2-ish months when the X3D part is out. But yeah. I'm not feeling good about it. Spoiler. 자, 9700X. 이게 이제 $360. So this came out at $360. $360. Let's also put this up on screen. 이것도 화면에 띄워놓죠. Notepad. Interesting. My chat window is broken. What the heck? Whatever. 예언 틀리면 자숙 영상 만드시나요? 아니요. 왜? 그냥 예측은 그냥 하는 거지. Unless 9800X3D has some magic plan, it'll be crushed by the now significantly cheaper 70X100X3D. Well, it won't be crushed. Well, yes, it'll be crushed in terms of performance per dollar, but not in terms of sheer performance, I don't think. 아님 말고의 반대. 아, 네, 어쩔 TV, 저쩔 TV, 아님 말고지. 안녕하세요. 저는 트위치에서 방송하는 리엘이라고 합니다. Okay. So, 9700X3D MSRP $360. No cooler. 7700X 300 or I think it was $400. No cooler. And you know, people are comparing. 이거 아, 고쳤는 줄 알았는데 안 고쳐졌네. 잠깐만. 합. Alright, I'm back. Anyway. 벌크로 $360? 아니, 이게 그냥 그 기본가요, 기본가. 리테일 기본가, 박스 기본가. 7700 박스 기본가는 $400였습니다. 아, 물론 이쯤 되면은 뭐 쿨러 따로 달만해. 700 시리즈 정도면은 8코어니까 따끈따끈해요. 그냥 하려면. Issue was measuring MSRP too is 7700X did not sit at $400 for long. We're getting there. Relax. And PvP like, how can we nickel and dime that thought process? So okay, here. 7700X, or non-X, sorry. This, you saw nothing. This retailed at MSRP was $330, just $330. 그냥 330불이었습니다, 얘는. 심지어 cooler included. 쿨러 포함. It was $329 after 4 months. Yeah, so if you're looking at the street price. Oh my god, I can't type right now. I may have drank a little bit of alcohol. MSRP. MSRP. $330. Yes, a wee bit of booze to fuel the rage. Well, real stream was that alcohol. So yeah. Street price, I think it goes for like $300 right now. I'm not sure. Let me double check. PC part picker. $282. Let's round it up. Let's round it up and just say $283 even. Even there, we're seeing $60, okay, $57 higher price. 자, 가격이 지금 7700X보다 excuse me. $57가 더 높습니다. $57. Am I doing that math correctly? No, it's 80. $77. $77. As low as $270 at Micro Center, but we don't talk about Micro Center here because Micro Center prices makes me angry that I don't have a nearby Micro Center. And the 77, sorry, I mistyped here. This is retailing the street price right now. $290 or something like that, if I remember correctly. $280, okay, $280 even. You know what? I think the 7700X pricing went up. And I wouldn't be surprised if that's because the 9000 series sucks so much. 정정당당하게 YSRP로 승부하자. 저희 채널은 가격은 그냥 미국 고정입니다. 미국 고정. 물론 YSRP도 중요하긴 한데 컴퓨터 부품 가격 따질 때는 미국 달러지 역시. So 9700X, we're looking at an increase in $80 compared to the previous gen. And the 7700 non-X even comes with a cooler if you need one. 그게 문제야. So the chips themselves are okay. They're not good. I wouldn't call them good. They're serviceable. But firstly, they're definitely not worth that increased price. Because, let's take a look at the performance. Game test. 자, 게이밍 성능. So here's 9700X stock. 자, 9700 스톡입니다. 기본. PBO 안 켰을 때. 그리고 많은 사람들이 PBO 키면 되지. PBO 키면 엄청 좋잖아. 젠5 이러고 있는데 자, 켜봤자 1% 올라갑니다. 성능. Oh, you can't see it. It's covered. Okay. Here. PBO 여기 켜봤자 1% 올라갑니다. 1%. Turning on PBO nets you 1% in gaming performance. And okay, so what does that mean? What does that 100% mean? Where is the 7700X and the non-X? 7700X at 96% of the performance. 7700 at 95% of the performance. So, you're looking at about 5% performance increase. 5%라고 합시다. 7700X는 105W TDP고 7700은 65W TDP거든요. 참고로 9700X는 65W TDP입니다. 그래서 사람들이 하는 말이 아니 조금 더 빨라졌고 전기를 덜 먹잖아. 근데 그 사람들이 관가하는 거는 7700이 성능이 95% 같은 동 TDP에서 95% 성능을 뽑는다는 거죠. 겨우 5.5%입니다. 94.9에서 올라왔자 5.2%, 5.3%입니다. 겨우. (5% at the same power). And they're asking what? Let's take a look at this pricing on the top left corner right there. So we're going from $280 to $360. That is a price increase of 28%, 29%. 가격 28% 올려놓고 7,700에서 쿨러 빼먹고 they remove the cooler, they increase the price by 28%, and they're giving you a chip that is 5% faster. 5%! And guess what? Oh wait, guess what? The 7800X3D is 10% faster than the 9700X stock. And you can find a 7800X3D for, drumroll, 7800X3D 얼마인가요 그럼? 9700보다 10% 빠른데 $367입니다. 9700 대비 $7 더 내고 (10% increase in price) and I mean performance for what is it? What's $7 out of $367? My mental math fails me. That is 7 out of 367. 2%. You're paying 2% more. 783D 원하면 개추. 7800X3D original MSRP was $450. Yeah, fair enough. Fair enough. My mistake. Street price. MSRP $450. I gotta fix that. Sorry, let me just take 2 minutes to fix something. Da 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 da. Ba 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 ba. Okay, there we go. It's fixed. Okay. Suzuri hari hari ha. $4,450. I'm not drunk. So you're getting 10% extra performance for 2% more dollars. Who is the 9700X for? 도대체 9700X는 누구를 위한 것인가? Who is this CPU for? Is it for gamers? No, they can get the 7800X3D for the same price. Basically the same price. You know what? Okay, let's go over this as well. This is the current price. But guess what? It was retailing for $340 just last month. Well, almost. A month and a half ago, it was retailing for $340. That's $20 less than the MSRP of the 9700X. 7800X3D 세일 가격이 한 달 반 전에 $340였습니다. 9700X보다 $20 낮은 가격이죠. 77X랑 77 단종 맛볼래? 아니 내가 걱정하는 게 그거야. 아니 이 자식들 신품 팔려고 가성비 좋은 옛날 거 가격 올리거나 단종시키는 거 아니냐고. 모르겠네. 그럴 것 같진 않아요. 단종시킬 것 같진 않고, 왜냐하면 이제 TSMC에서 벌써 주문을 넣어놨기 때문에 얘네한테서 계속 사와야 되는데, 그 공정에. 왜냐면 얘네 9700이랑 7700이 공정이 다르거든요. 9700은 5나노 플러스 4나노라고 하긴 한데 5나노 플러스죠. 그리고 7700은 5나노. 그래서 공정이 달라가지고 그 5나노 공정 주문한 거를 이제 9700으로 돌릴 수가 없어. Honestly, I think AMD should ditch the non-X3D single CCD so consumer processors. You know, I think so too, but we'll see. We'll see what happens in the future generations. Not this generation though. Shawnee Bay! Welcome, Raiders! Welcome, welcome. Hello. 어서 오세요. What's a computer? It's a thinking box. It's a box full of thinking sand. We confuse a rock into thinking. Yeah, so. Okay, so the 9700X is not for the gamer. Because it performs worse than the 7800X3D. Performs worse than the 7800X3D. For the same price. $7 less right now. Street pricing. Or 5% better than the 7700X and the non-X. For $80 more. So yeah, it's not for gamers. If it's not for gamers, is it for, I don't know, maybe people who do production stuff? But then why would you buy a single CCD 8-core part if you're doing production part? If you're in a production environment that requires a lot of cores, you're not going to go for a 9700X. You would get the 16-core part. And we'll talk about that later. Can't believe the Thinking Sand is smarter than me. You know, Thinking Sand may be smart in some ways, but not in other ways. Thinking Sand still hallucinates. So, okay, it's not more performant. The 9700X, based on Zen 5, is not more performant than Zen 4. By much, at least. It's 5% more performant at the same power level. Is it much more efficient? No, well, I just mentioned the power level. So, spoiler. Single thread efficiency. So the way Tech Power Up measured single thread efficiency was they ran Cinebench divided by the number of points they got by the power used by the CPU. So what you're seeing is how many points you got per watt of the CPU use. 9700X stock right here, 6.8 points per watt. for a single thread Cinebench run. A 7700 gets 7.4 points. The 7700X is a higher power limit part. Thus, it does get lower points per watt. And people are looking at this only comparing the 9700X to the 7700X because they are both the X parts, forgetting that the 7700 non-X exists. They're like, oh hey, the 9700X is about like, I don't know how many points, like 20% more efficient than the 7700X. But no, if you're actually looking at the 7700, it's less efficient. And taking a look at multi-core, right there. Multi-core on the right side. 9700X stock gets 15.7 points. And the 7700 non-X gets 15 points. So it's a little bit ahead. But not by much. Not by much at all. Now, the 7700X, as I said, is a higher power part, so it'll boost to a higher clock speed past the sweet spot on the voltage frequency curve. So CPUs, they require higher voltage at higher clock speed. And past a certain point, you see a diminishing return, where you're putting like 10, 20, 30 more % in voltage, but not getting anywhere close to that in terms of clock speed increase. That is why lower power parts generally have higher efficiency. For example, you see the 7900 non-X there. That's a 65, I think that's or is that an 88? 95, I mean. Let me just check my numbers. Idle power, Cinebench power. 7900 non-X is a... Yeah, so at multi-core, it's using 74 watts, so I think that's a 65 watt TDP part. The package power is higher than the TDP. I think that's the 65 watt part, so... That's why you see the 7900, Zen 4 base 7900 at the top of this chart. Way past the 9700X. If we're cherry picking numbers, if the proponents of the Zen 5 efficiency are saying it's like 40% faster, well, we can do the same thing the other way around. What's 20.7? I think that's like 30% faster. Divide by 5, 15.7. 32%. Sorry, more efficient. We could say that the Zen 4 is 32% more efficient than Zen 5. If we want to cherry pick numbers like that. 자, 9700X가 를 7700X에만 비교해놓고 야, 9700X가 더 훨씬 전력 덜 먹네. 훨씬 더 고효율 CPU네. 그 사람들이 모르는 거는 7700 65W 파트 시네벤치 스코어를 점수를 시네벤치 돌리는데 사용한 평균 와트로 나누면은 9700X는 와트당 15.7포인트, 젠4 7700은 15.0포인트. 차이 거의 없습니다. 이거 몇 퍼센트야? 3% 되나? (5%) Zen 5, literally Zen 5% more efficient. How about gaming? 그럼 게임할 때 시네벤치 말고 시네벤치 같은 신데렉 벤치마크 말고 진짜 게임 돌릴 땐 어떠냐? Okay, fine, but okay. How about in a real world benchmark? How about a real world application, not a synthetic benchmark like Cinebench? Well, bad news for you, because 9700X less efficient than the higher power part 7700X. Because when running games, higher power doesn't really mean much because the CPU is not hitting that power limit anyway, because you're only using a few cores. And then we have the 7700 non-X, even more efficient, far more efficient. 3.02 divided by 2.59. 17% more efficient. 7700이 9700X 대비 17%더 고효율. 이게 말이 되냐고. 아니면은 7800X3D 5 나오면은 7800X3D는 4.25 나누기 2.59. 64% 와트 대비 효율이 64% 더 높은 거죠. 64% more efficient at playing video games, and you're getting higher frame rate. So, okay, Zen 5's not for gamers. How about some productivity? Let's say you're gonna use your... Now let's switch over to the 9950X, the 16-core Zen part. So here's a 16-core Zen 5 part. MSRP of... what is it? Here we go, $650. $7750X. There's no non-X for the 16-core part because they just use way too much power. The 16 cores just use way too much power to be power enveloped at 65 watts. You can use eco mode on them, but they're not that good at 65 watts. MSRP of, I think it was like 700 $700? Should be right here. That's a street price, but the MSRP was... $7950X, sorry. I think it was $700. Yeah, $700. Street price. $513. Let's say $14. That's $136 increase. How much performance do you get over the 7950X? 일단 가격은 $136더 높아. 그럼 성능은 어떤데? 성능. I don't know, maybe encoding? Maybe you're doing CPU-based encoding because X264 looks nicer than H264 or something. I don't know. X264, here we go. Stock, you are seeing 24.2 seconds on 9950X versus 24.8 seconds. What is that? That's a... .4% reduction in encoding time. To be honest though, Zen 5 seems to dislike H.264 in particular. How about AV1 encoding? Oh, it looks better. 52.7 versus 57.2. What's that in terms of percentage, though? 7.9% deduction in encoding time. Wait, how much more are they asking for that? $134. Huh. How about some other applications? Let's just go from top down. I don't know, maybe you're crunching numbers for, I don't know, scientific or mathematic, I don't know, engineering, I don't know. Y cruncher calculating pi digits. Wait a minute. Why is the 7950X faster than the 9950X? Huh. How about chess simulation? Okay. You're looking at 30.78 million nodes versus 28.26. Okay, so that's an increase. That's an increase there, at least. In terms of percentage, you're looking at 9% increase. Browsing, I don't know, it's kind of pointless because just about any CPU does okay at browsing. But okay, if you don't take a look at it, it's 397,000 points versus 390,000 points. More browsing. How about some actual? If you're using it as a workstation, machine learning and AI. $99.50x, 111.4 seconds at GPT-2 inference. 7950X, 130. So a decent bump there. That seems like a 15% bump-ish. More AI inference. Stable diffusion. Now, these are really GPU or NPU workloads. You're not really going to be using your CPU for inference. But if you wanted to, if you really wanted to, you're going from 128 seconds or 129 seconds to 113 seconds. Okay, that's a decent improvement. That's like, I don't know, 16, 17%. How much were they asking for it though? Alright, $134 more. Which is... Let's just do the quick math here. The price increase they're asking for the 9950X over the 70... Oh, I wrote that wrong. Sorry about that. 7950X is 26% increase. The numbers just don't add up. Oh, sorry, I was not paying attention to chat. I was too focused on just letting you know how bad of a decision it would be to jump on Zen 5 right now. Why is my chat window not working correctly? Sorry, hold on. It's been 3 days since streamer last read chat. Rare. Is the chat thing due to some sort of AVX 512 improvement? Possibly. So that's one thing that Zen 5 hugely improved. It now has native support for AVX 512 instead of Zen 4, which I think, I don't know the details on the workings of CPUs, but I think what they did was doing it in 2 parts in 256 with whatever in 2 instructions. Don't quote me on that. Anyway, it's less efficient on Zen 4. MP3 encoding poggers. Let's take a look at MP3 encoding. I actually do quite a bit of encoding, audio encoding too. So, 58.8 seconds versus 64.3 seconds. So, that's about... what is that in percentage? 643. About 8.5%. Which X264 preset is that? That was... slower at CRF20. When I do X264, I use very slow for the placebo improvements. So whatever happened to the 20 to 40% IPC uplift? Well, the 40% IPC uplift that was part of the rumors, probably for AVX 512 heavy. Calculations. So, it does do well in some instances. Yeah, the charts are making it look like a rebadge, eh? But no, there are some noticeable improvements. Like if you look at the AI, where it sees like whatever I calculated earlier, I think it was like what, 16%, 17%? Or if you look at, I don't know, game dev. Let's look at game dev. Oh, maybe we shouldn't have looked at game dev because it's actually doing worse than the 7950X. 야, 언리얼 5 개인 디벨롭먼트 보니까 7950보다 못난데 이거? Okay, how about Git source code management? Oh, now we're seeing some improvement. That looks like, I don't know, maybe like 15, 16%? 223 seconds to 209 seconds. 209.6. How about... Well, I don't think you would need a 16 core. I don't know, maybe you do. How about scientific? Simulations. 131.9 seconds versus 140. So that's about 7%. 20% uplift was a naming. 7950 to 9950. I think it's the server application that it does really well at. Lower is better. 2651 for 7950X versus 2929. Let's just not look at VirtualBox, okay? Ignore VirtualBox. 9950X stock. For MySQL, MySQL, I mean, 14,939 transactions per second versus 14,030 transactions per second. But why would you run server applications on a client desktop machine? It could be for a small medium business. Not everyone needs a Bazillion Core, Xeon, or Epic part. How about web hosting? 23.9 seconds versus 24.8 seconds. Oh boy, it's not looking good. Okay. But you know who had good numbers for the 9950X? Phoronix, because they are testing on Linux. If you want to use it for a small server. I don't know, maybe you do. Let's take a look at the Linux numbers. Linux kernel compilation. That's a decent increase right there. I think that's about 17%-ish. So AMD promised 16% IPC uplift. And the 9950X and 7950X basically has the same clock speed. Oh, okay, no, that's the 15%. So not quite at the AMD 16%. How about FFmpeg compilation? 2577, 2962. 23% reduction. There you go. Something that's finally greater than 20%. Gen 5 Mesa. Not sure what LLVM is. Large language something virtual model? I don't know. Johnny B, thank you for the bits. How about compression? 7-zip compression. 194,827. 186099. I'm typing the numbers wrong. But yeah, that doesn't seem like a... Wait, no, that's the extra UD part. Okay, where's the 7950X? There we go. So 194.8 divided by 178.9. Uh, 8.8% increase in 7-zip compression rating. How about decompression? Oh, they didn't test decompression. Maybe the compression rating is based on both compression and decompression. Because I know, from what I remember, Zen 5 does better in one, excels in one, and does a little better in the other. This stream is Real Rans Ryzen Regressions. The R4. DAW. Now that looks really good. .55 divided by 7.53. Ah, never mind, it's only 14% increase. How about Blender? If you're not using your GPU for some reason. I don't know a lot about Blender, but is there a reason to run it on CPU instead of GPU? So you're seeing 10.4% decrease in time. Below the 16% average IPC promised by AMD. I don't know, I only use it for modeling. Do you model on your GPU or your CPU? I guess modeling's on the CPU and just rendered on the GPU? Or stresses the CPU, but I don't know. I don't know. Blender, Blender, Blender. I create the model and export it to use on Unreal Engine 5. It's not a resource-intensive task usually, unless you're sculpting high-res meshes, which is probably a CPU-intensive thing. Okay. Here, geometric mean of all test results. $126.34 over 107.25. So Phoronix apparently saw 18% increase in performance going from 7950X to 9950X. So for some applications, there's a lift. There's an increase that's more than 5%. But wait, how much was the price increase again? 26%. Wait, the performance increase is what? 18%? The math does not add up. Remember the good old days when a new generation of parts come out? They're like the same MSRP, just better. Like, even considering the sale price, they're usually like on par. So Zen 5 exists for the 3 to 5% of desktop PC market. Zen 5%. You know what really left a bad taste in my mouth though? Prior to Zen 5 release, these are the things that AMD said. AMD were incredibly misleading with the Zen 5 performance promises. So this is what AMD said. At Computex 2024 in June, they said Zen 5 non-X3D won't be faster than the X3D, but it'll be close. Close? I don't know. What does that mean? Is 10% close for using AMD? I don't know. Maybe they consider that close. They also said this. The 9950X outperforms... Sorry, the 9700X... No. The 9900X, so the 12-core part, outperforms 14900K at gaming. Pricing. Okay, where's that slide? Where's that slide that I want? I forgot to load this one. Computex? Okay, so it was a 9950X. Comparing it to the 14900K. Gaming leadership. And yes, everyone is aware, well, most of the people in this industry, tech, or like people who are keen on tech, like CPU cycles, are very, very keenly aware that yes, both AMD and Intel cherry-pick their numbers to show their product in the best light possible. But if they're showing 4% to 23% increase over the 14900K, shouldn't it at least tie or surpass, even by a little bit? Even by a little, tiny little bit? 14900K at 105% of 9950X. Behind by 5%. When your marketing slide shows, where was it? 4% to 23% in increase in your cherry-picked numbers. You know, even these numbers are probably not accurate. Let me take a look. Hitman 3, what does TechPower test? They may have Borderlands. Baldur's Gate 3... Cyberpunk? Is that on here? Okay, Cyberpunk, AMD slide showing 13% gain over the 14900K. $9950X at 195.2 FPS over the 178%. Actually, that is a decent increase. What is that? 195 divided by 178. So TechPower's number showing 10% increase versus 13% from AMD. Fine, okay. I remember the Intel 4-core doldrums. You know, even those, even from Haswell to... sorry. Core 4 Quad to Sandy Bridge to Haswell. I'm cutting every other generation because, you know, Intel did the TikTok thing where they make huge architecture changes and then improve the node. Architecture changes and then node improvement. So, Sandy Bridge, Haswell, and Skylake, those were 2 generations apart. Which means they came out every 2 years. Or they were 2 years apart in terms of release cycle. Those saw, if I remember correctly, those saw 20% plus, even on the same core count. At least those CPUs saw 20% increase. The only way to recover Zen 5 is to tank the prices. I expect Zen 5 refresh mid-2025 where they release non-gimped Zen 5 parts. So I don't remember this, but apparently at Computex, Dr. Lisa Su said Zen is going back to an yearly cycle. Release cycle. I don't know what she means by that. I don't know if she even said that. I just saw it on a YouTube comment. However reliable that is. If that is true, if she said that, then yes, I think it's just gonna be a Zen 5 refresh. Are they gimped, or is it just like not using 3 nano? No improvement. Yeah, 5 nano to 4 nano, which is 5 nano plus, isn't really a big improvement. However, it still is a node reduction. It has way more transistors. So here's a transistor count for 7700 non-X has the same transistor count as the 7700X. So for the 8 cores, this is not counting the I/O die. This is just the cores, 8 cores. The 7700 on Zen 4 has 6.57 million transistors. The 9700X has 8.3. So let's do the calculation here. 9700 has 8.315, I think. I'm not sure if that's billion. That might be a billion. I think that's a billion. I don't know if they're a European side or... I'm not sure if there's a decimal separator or 1,000 separator. Either way, we're just looking at the ratio, so it's not very important, the exact numbers. So we're looking at an increase of 6.57. So in terms of ratio, we're looking at 8.315 divided by 6.57. 26.5%, 6%, 26.6% increase in terms of transistors. Where is it going? Is the cache increased? No. 7700 has 32 megabyte of L3 cache. 9700X has 32 megabyte of L3 cache. Does it have more L2? Oh, here we go. 1 megabyte per core for 9700X. 1 megabyte per core for 7700 non-X. L1 cache, 80 kilobyte versus 64 kilobytes. So there is an increase in cache. Just a little bit. All the extra transistors are for the deactivated NPU. No, I don't think it's... Yeah, I know you're being facetious, but it's not at the NPU. So they apparently made improvements to their branch prediction, as well as adding more... It might be on here. But yeah, they did make quite a bit of architectural changes, so it's not a rehash, it's not a rebadge like the 13th and 14th Intel desktop parts are. Improved branch predictions, Pentium 4 moment. A little birdie did tell me that Zen 2 team worked on Zen 5. I don't know how they work behind the scene. Frankly, I don't care. Just give me good products for good pricing. Zen 5 as is right now does not have good price. It's for almost nobody. Except for if you need AVX 512 heavy, if you have AVX 512 workload, or those few applications that where Zen 5 actually excels at. Well, excel, quote unquote excel. You know, 15%, 20%. So here's a problem. There are some proponents of the X3D part. Hey, just wait for the 9800 X3D. Just don't bother with the 9700X. It's that simple. It's that simple. The problem is, if the base part, base 9700X, is only 5% faster for gaming compared to 7700 and non-X, or non-X and 7700X, is the ratio gonna differ between 7800X3D and 9800X3D? Is the ratio gonna be different? Or is it just gonna be 5% faster than the 78X3D while costing 20-something% more? AMD's, one of AMD's, I can't remember if it was, their marketing exec or if it was their engineer. I don't remember if it was Mike Clark or Donnie Woloski or someone else, but someone said they were making improvements. I think it was Donnie Woloski. The marketing person, the marketing exec, said that they were making improvements to the 3D V-Cache. I don't know what improvements. I might be able to find it.
Parts, you know, kind of those traditional 16, 12, 8, and 6 core CPU like cache and stuff like that. Like, what is the exciting part about these?
This is, I mean, it's a. You're absolutely right. If you look at the specs, it like, well, that looks similar to last gen.
Okay, here. So let me just clarify first. Donnie will. I'm very sorry, Donnie, if I butcher your name. Donnie Woligroski, Senior Technical Marketing Manager at AMD.
And if you look at the performance, you're like, oh, okay, this is a pretty major architectural upgrade. We're talking about 16% IPC. So not only do we have more performance, but if you look down the stack, we actually drop TDPs.
We know how that went. 5% more efficiency.
Being running really hard on the desktop CPUs. Hey, these things are way too. Yeah, we're dialing the efficiency knob and stuff.
Like what can you do, right? We've got a node improvement here with Zen 5. It's a new architecture, new node. It can, the residency is water, just turn on, everything's overclockable. And you know, we had a 65 watt 700X, and it apart. It's just
X3D options of this. Is this just how it's going to be? Is that you're going to come out with the non-X3D first, and then the X3D later, and make people?
I can't talk about unannounced products. What I can say is AMD is committed to X3D, not just the status quo, but like improving it. So
here's a part.
Status quo, but AMD is committed to X3D, not just the status quo, but like improving it. So there's really great technology that's being worked on, and yes, we're going to make you wait a little longer before we make any more announcements.
So they're not just satisfied with the status quo. They're improving the X3D technology, the 3D V-Cache technology. Okay. So how much is that going to help the 9800 X3D? Can we even trust AMD to make? Can we even trust what AMD are saying there? Is this improvement really going to show up as a benefit to the end user? Or is this some kind of improvement that literally doesn't matter for a gaming workload? After there, after slides like, did I close it? I think I closed that. Here, no. After slides like this, or this, can we even trust AMD to really mean what they're saying right there? AMD also said, so that was Computex. During 2024 Zen 5 Tech Day, which was, I believe, in July, they showed a slide showing the 9700X outperforming a 14700K in both gaming and productivity. Let me see if I can find that. Must be something else here. Where was that slide? No, I think this is the... Yeah, it's not this one. I want that particular slide because it's so egregious. It's so bad that I want it. I hate Google so much, it's so bad. Was that the technical deep dive? I don't think that was the same day. Oh, here we go. Wait, no, that... Okay, no, it was the technical deep dive. Why didn't I see this slide earlier? So this is the slide that I wanted to show you guys. 9700X beating the 14700K at gaming and productivity. Gaming leadership. Productivity and content creation leadership. Let's take a look at the review again, shall we? Because we weren't comparing to the 14.7. We were only comparing to the 77. So compared to the 14.7, gaming, 9700X at 100% obviously, relative because it's all relative to the 9700X. Whoops, I think I see the 14700K actually ahead of it. How about productivity? I don't think Tech Power Up has like an average of like all their productivity suite, but I don't know, let's just look at a couple. Machine learning and AI. GPT-2 inference. If I'm not mistaken, training is what you do beforehand, and then to use a model, when you're using the model, that's inference. So 9700X takes 125.7 seconds. 14700K, 104 seconds. 100.4 seconds. So 147K is ahead, because the lower the better. How about encoding? AV1 encoding. 97x, 69.2 seconds. 147K, 64 seconds. So 97x at PBO max can actually tie 147K. How about HEVC? 65.3. 14.7 all the way up at 41.9. It's like 30% reduction. Wonder about the 9950 X3D, because someday I might cross-grade to it. You're on the 7950X, right? Not X3D. I would stick to it, honestly. Oh, and one more egregious thing about Zen 5. So here's the core-to-core latency for 7950X. You can see that as it has always been for Ryzen parts, when you're talking between CPU cores that are on different CCDs, so CPU 1 and CPU 0 and CPU 16, you're looking at about 75.8 nanoseconds of latency. Whereas within the core, you're looking at 6.3 nanosecond all the way up to 7.6 nanoseconds. Cross CCD, you're looking at 75.8 to, 77.9. So yeah, talking between CCDs takes way longer, which is why single CCD Zen Ryzen CPUs have always been tied or better than dual CCD designs. But it hasn't been that bad. Zen 5 though? Intra-CCD. Within CCD, we're looking at 6.3 to 7.6 for Zen 4. Zen 5, we're looking at 20 to 23 within the CCD. You know what's really sensitive to core latencies? Gaming. Inter-CCD, between CCDs, we're looking at 190, 185. Okay, there's some lower. 170, 68, all the way up to 205. That's more than double the increase in latency compared to Zen 4. That's literally 100 nanoseconds on top of Zen 4 latency. What are they doing? Why is it so bad? It's so bad that AMD in their review guide actually suggested reviewers to install a specific driver that was initially meant for the dual CCD X3D parts. Because the 7900 X3D and the 7950 X3D, the 12 and 16 core X3D parts, only had 3D Vcache on one of the CCDs. So when those parts came out, AMD had a driver that parks the non-X3D CCD when games are running, so that games could run the game process would only run on cores that are on the 3D Vcache CCD. In their Zen 5 dual CCD review guide, AMD actually asked reviewers to install that driver that parks one of the cores. Well, I don't know if it's the same driver or if it's improved, if it's updated for the Zen 5 CPUs, but either way, they're actively parking cores because the cross CCD latency is so bad. It's just crazy. What are they doing? I wonder if some games run faster if you use Task Manager to limit a process to a CCD. Yes. Yes, very much. I know a friend of mine that does that for virtualization thing he uses. Yeah, probably helps there too. Will they ever do anything interesting with Zen 4C, Zen 5C? I have not heard anything on the desktop front about using the compact cores. I would love a X3D CCD and a compact 16-core CCD CPU. That'd be pretty cool. Give us that sweet, sweet 3 nano. Apple laughing in 2 nano. Yeah, we're gonna have to wait for 3 nano on desktop. What's Arrow Lake on? Is Arrow Lake on Intel 2? Arrow Lake will reportedly be built using Intel 20 angstrom, so 2 nano. But you know, with Intel, 2 nano actually means like 3. Conflicting messages. Whichever, I don't know. TSMC 3 nano and Intel 2 20 angstrom are, I think, gonna have similar density. When you're done ranting about AMD, can you give me an in a nutshell recap of the Intel situation? I only heard about high failure rates on Elder Lake and Raptor Lake. Did they figure out what's happening? So it's actually only Raptor Lake. And I will talk about it in the actual Real Tech Talk, but yeah. The gist is that in order to hit the ridiculously high clock speed, the Intel CPUs, specifically all the Raptor cores, Intel has not given, they have not announced the root cause, but people are guessing that it's the top clock speeds that require crazy voltage. 149K requiring up to like 1.59, almost like sometimes even beyond 1.6 volts to hit that 6 gigahertz clock speed. Same thing for the 139K to hit that 5.8 or whatever gigahertz. They're requesting north of 1.5 volts, which is really high, which is crazy high for modern, like sub 14 nano chips. I think that's the kind of voltage that we saw on CPUs back when, like, oh, what's that note? Was it 100 nano? Back in Pentium 4 days. Pentium 4 voltage. Literally Pentium 4 day. And we can't use that kind of high voltage on modern nodes because everything is so much closer together. Lot more heat generated in a... I don't know the exact issue. I think I've also heard something like, because the gates are so close to each other, electrons can migrate between them through the insulator, causing problems at high voltage. I'm not an expert in the lowdown of this, so yeah, whatever. But yeah, we're seeing a voltage range that's from 20 years ago. Leakage. .45 volts. That'd be fine if it were only 1.45 volts. No, these CPUs are literally requesting 1.6 plus. And the latest Intel microcode, the X0129, I think, 0129X or whatever, limits the top requested voltage to 1.55. Limited to 1.55. Oh yeah, there you go. Northwood, 130 nano. We're not even at 1/10 of that. We're at like 1/20th of that. In terms of the gate sizes, gate pitch. Crazy. By the way, AMD CPUs, they top out at 1.35. Let's see, voltage. I think Gamers Nexus video had voltage.
Every aspect of
I thought they had voltage graphs somewhere.
are pulling the data on the microsecond scale. The second limitation. If we plot the
Oh,
max
here we go, voltage. What's kind of funny is that the 97, so Zen 5 part is actually requesting higher voltage than Zen 4. During gaming anyway, in this specific game. So you see the Zen 5 topping out at, I don't know, 1.4. Zen 4 topping out at 1.3, I don't know, 7-ish. And then you have Intel going all the way up to like 1.55, 1.6. So yeah, Intel initially said they would not be extending their warranty. They would not be recalling. And then after backlash, public backlash, they're now saying they will extend the warranty on retail CPU, but not on tray CPU. And then I think they may have gone back on that too, and then now they're saying they will accept tray CPU as well? I'm not sure of the latest, but yeah. Retails are getting, I think, like 2 years extra in warranty. They're still not recalling. And then all the meanwhile, GN, while talking to an Intel insider, found out that Intel Raptor Lake CPUs had oxidation issue, causing failures back in 2022 or something, 2023. And after that, Intel came out with a statement saying, "Oh, that was only a problem back then. We have fixed it since." They never recalled any CPUs during that time, and there are records that they denied RMAs on their broken CPUs during that time. The tray CPUs have to go through their vendors for the vendors, okay. Yeah, if you're lucky enough to have bought your tray CPU through a vendor. If you are living in Korea, where tray CPUs are extremely common for retail, or if you're living in Europe, where I think they're also common, I guess you're SOL. 한국에서는 이제 트레이 그 벌크 CPU 많이 팔잖아요. 인텔 벌크 CPU면은 워런티 못 받는 거네? 받을 수 있나? Intel better watch out. My competing x86 CPU is on a whopping 1 meter process. From what I've seen, Push System did say they've seen issues with the 10th, 11th gen CPUs with about similar rates of failure as the 13th, 14th gen at this moment, as of this moment. I think their numbers are not very big, their sample. Their 12th gen numbers look good. But overall, I think Puget Systems' number of systems that they have in their graphs isn't very big. Did I say everything I wanted to say about Zen 5? I talked about efficiency, I talked about performance, I talked about the value. And I also talked about the X3D. If 9700X is only 5% faster than 7700, is 9800 X3D going to be faster than the 7800 X3D by anything more than 5%? While Donnie did say, AMD's senior technical marketing lead, I think, did say that they're improving X3D, but can we trust AMD on their words? Where's that slide? Gaming leadership. Creativity leadership, when we know that these are patently false. Literal BS right there. How about the 9900X? Faster than the 14900K at gaming. Oh boy. Are there any winners in the Zen 5 lineup so far? I would say no. Even the 16 core part? No, okay, maybe the 16 core part, where there is no alternative. No winners in a burning house. Just don't trust pre-release marketing for anything. The problem is, AMD had been good, or had been generally okay with their marketing slides previously. For Zen 4 launch, it is quite on point. Sure, their benchmarks were a bit cherry-picked, but it still didn't show their CPUs being better than their competitor like this. The winner of Zen 5 is all the sites and channels that made ad revenue. Pretty much. It started with RDNA 3. I think. The marketing. RDNA 3 marketing was so inaccurate. Alright, AMD makes video cards too. Yeah. So here are some additional tidbits. So apparently, Windows... So Steve from Hardware Unboxed were talking to AMD about their poor CPU performance. They're like, is this real? Am I getting the right numbers here? And AMD suggested that Hardware Unboxed run their Zen 5 CPUs under the administrator user. So this is not a regular user that has administrative privileges. This is an actual Windows user called administrator that's typically hidden, where you have to use a console command to make it visible. And it's kind of like the admin account of like the XP days. And Hardware Unboxed found that on average, you see a 5% gain in performance for Zen 5. So going from Zen 5 non-admin to admin, about 5% gain. But the problem is, Zen 4, so 7700X, also saw a gain. Admittedly less than Zen 5's 5%, but it still went up by 3%. So when they're both running on admin account, Zen 5 only saw an additional 2% over the Zen 4, so it's not... I don't think this is it. And then Tech Power Up did a silly piece that I think is very, very silly. Where they're like, oh, just disable simultaneous multi-threading, known as hyper-threading on Intel land. We found the missing performance. Zen 5 tested with SMT disabled. So overall, by disabling SMT, they saw a 2.5% improvement. 2.5%. And then on the 7800X3D, the performance stayed the same. 77X, the performance dropped by 1%. But really, disabling SMT isn't something new. It's been something that was mentioned all the way back at Ryzen 1000 series, where I think they saw more than 2.5% by disabling SMT on those. It's really too bad they only tested 3 CPUs with SMT disabled. Yeah, 2% is imperceivable in practice, and Tech Power Up's argument was that whereas Zen 4 drops in performance in games, Zen 5 increases when you're disabling SMT, thus giving a bit more improvement. But that's only 2%, 2.5%. over the pre-existing 5%, so it's still a single-digit improvement. Gen on Gen. I almost said Zen on Zen, which also makes sense, but yeah. I guess if you add that 2% from the Hardware Unboxed investigation of running an administrator account onto this 2.5%, on top of the 5%, then you're finally seeing that 10% gain, this double-digit gain. Oh my god, double-digit. Gain over Zen 4 if you're using all these techniques. Well, congrats. Guess what? You're paying 20 more percent. This is like optimizing an AC, which we'll be doing tomorrow. Come back tomorrow for the Armored Core co-op mod collaboration stream. So yeah, this sponsor has been streamed by no one else other than me and you viewers for being here. Tomorrow is the bullying real stream. No, it's not gonna happen. I'm too good to be bullied in AC. Anyway, Zen 5 is a flop. Except for in very, very specific non-gaming situations. Don't get Zen 5 right now. Definitely wait for the X3D part, but I don't have high hopes for it. It's gonna be a single-digit improvement over 7800 X3D. 젠 5 9800 X3D는 7800 대비 한 자릿수 성능 올라갈 겁니다. 제 예측으로는. So yeah, that is the prediction of the stream. 98 X3D is only going to be a single-digit improvement over 78 X3D. Okay, let me add this. At the same power level. Because there is a chance that 98 X3D releases with a higher power target. Can't wait to bully Riel with unfriendly fire. Yeah, I suggested to Suzu that we should play with friendly fire on but targeting disabled. I think that's gonna be fun. So if we have two of us rushing an enemy, both with melee weapons, we're gonna be hitting each other too. Mato Stompo invasion time. Good luck, you're not even gonna last 10 seconds. Use a bomb that disables target lock. Yeah, the chaff. Oh, yeah, okay, I just wanted to add one more thing regarding Zen 5. So if you were on the fence about getting a 7800 X3D when it was having that ridiculously good sale a couple months ago, seeing prices low as $335, but you're like, maybe I'll just wait it out, cause Zen 5's gonna be out soon, right? And you passed on this deal. And now that that same CPU is selling more than like $20 higher, and you're presented with the option of getting a 9700X, which is the same price, or waiting out till the 9800 X3D, which is most likely going to be a single-digit improvement, I think you're gonna be feeling really bad about passing on this deal. Passing on this deal. Because AMD were making claims like Zen 5 is a great gaming CPU, as we explored earlier, those claims. Gaming leadership. Because the 14700, or no, where's 14900K is only 5% slower than 7800 X3D. And AMD are showing 9900X being, at least in their average, 10% faster than 149K, which means the 9900X should be faster than the 7800X 3D. So if you saw this slide and you're like, oh hey, Zen 5 is going to be great for gaming. Well, you just missed out on that great 7800X 3D deal. Sucks for you. That's really too bad. And guess what? Guess who that person is? Guess who that person who passed out on the great X3 deal is? It's me! $390?
파티 원.
Shawnee B, thank you for the bits. 390 Maple dollars for 7900 X3D. That price is lower than the all-time low price of 7800 X3D. Which was $400. Doesn't even show up here because it was a store price and an additional coupon price plus in-store deal, which brought it down to $400. So I could have gotten a 7900 X3D for cheaper than a 7800 X3D. You big beep 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 beep. Oh wait, no, you're saying that's me. Yes, drag him off to the gulags. Man, I'm glad AMD learned nothing from almost going out of business versus Intel. Yeah. Sitting on their laurel during the Aslan X2 days. No, they're learning from Intel. 14 nano plus 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 plus. Learning from the best. I'm so mad. I am so mad I passed out on this deal. Where is it? 79 doko. Oh, this is the American site. That was such a good price. Yeah, but 7600 X3D plus a 7600X for $390? That's a lot of cores. I don't care if it's 5% slower than the 7800 X3D for gaming. I'm getting almost the same gaming performance plus all that productivity for extra cores. Let's be financially responsible. Real buys a 7600X, 7800 X3D. Finally, fast TITS performance. Yeah, no more lag. Yeah, I'm mad that AMD lied to us. Making me think that Zen 5 was gonna be good. Instead, we got Zen 5%. Yeah, definitely zero bias in my review of the reviews. Currently using the 7600 non-X machine right now. Rip Bangtok. Bangtok died when Twitch Korea died. Well, a month or two after that. Why do you think thinks Real sets things up? No, I had those commands. It just died because the Twitch Korea bot died. Ah. Yeah. I'm not excited for Zen 5. Zen 6 where? Actually, Zen 5 being so bad has dampened my expectations for Zen 6 as well. And Arrow Lake as well, actually. Not because of Zen 5, but I'm not expecting much from Arrow Lake either. Because yes, they might be more efficient and have better performance per watt, but because Raptor Lake is so power hungry, Intel are promising a 100-watt reduction in power usage. So if we're looking at 150-watt CPUs, the performance improvements overall might be a wash. TSMC rules the world. It's up to them selling 3 nano capacity to AMD. Well, the reason it's not just that. I'm sure AMD and Intel could get some cutting edge nodes if they wanted to, but I think they're not using them because, first of all, these cutting edge processes need to be optimized. That's why they're generally used on mobile chips, which are far smaller, where the defect rate wouldn't be detrimental. There was a great wafer defect visualization. There was a website that had a great visualization of chip size versus defect rate. So, say you have a 30 centimeter wafer, a 300 millimeter wafer, the typical size, and you have 5 defects on it that are like pea-sized, whatever. Smaller, probably. Most likely. So if you have 5 defects on a 300 millimeter wafer, if your chips are tiny, if you can get 200 chips, 200 mobile chips, I don't know the exact number. Say if you can get 200 mobile chips out of that wafer. If only 5 of those are defective, your defect rate is only 2.5%. But if you can only get 20 CPUs, desktop CPUs out of that same wafer size, at the same node, 5 out of 20 is 25%. And that's why leading cutting edge nodes are better for smaller chips. Yeah, that's half the reasons for using chiplets, so that each chips can be smaller. But anyway, I think even a Zen CCD is still bigger than mobile chips. How big is I don't know. Snapdragon size. Oh no, it's one of these Garbo signs. Package size. Wonder if it's even listed. These are phone sizes, not the chip size. Yeah, I don't know. Transistors. That's not important. This rant was supposed to be about AMD only anyway. So yeah, don't buy Zen 5. Lower your expectations regarding 9800 X3D. Jump on Zen 4 deals if you see any good Zen 4 deals. 삼사방님 어서오세요. 아, CPU에 관심이 많죠. 그럼요. 젠 5는 하지 마시고 일단은 9800X3D 별로 안 좋을 겁니다. 아마도 예측. 그리고 젠 4 7800X3D나 7700 굿딜, 핫딜 찾으시면은 그냥 사세요. Across CCD latency, it's like back to OG Threadripper or something. 네, 7800X3D에 5에서 10%밖에 안 나올 것 같습니다. 한 자릿수일 거라고 저는 예측하고 있어요, 지금. 그냥 5%라고 예측하고 있어요, 저는. 5%. 뭐냐면은 9700X가 5% 더 빠르거든. 7700 대비. (7700에) 3D V캐시 X3D를 댄 게 7800 X3D고 9700X에 X3D를 댄 게 9800 X3D니까 별 차이 없을 겁니다. 터바나르 튤립님이 어서오세요. 컴퓨터 보고 있는 건 아니고요. 그냥 젠 5에 대해 주저리 저저리 설명이 아니고 그냥 떠들고 있는 겁니다. Thanks for the stream. I'll be in and out lurking. Alright, see ya. The stream's over anyway. I'm winding it down right now. So how does AMD make money out of this? I have no idea. 3나노는 애플이랑 엔비디아가 다 가져간 건가? 방금 그 얘기 영어로 하고 싶긴 했는데요. 데스크탑 CPU에 최신 공정을 쓴다고 딱히 좋기만 하진 않은 이유가, 물론 이제 젠 시리즈는 치플렛이어서 그렇게 크진 않지만, 그래도 제가 알기로는 조그마한 모바일 이제 폰 CPU보다는, 폰 SoC보다는 훨씬 크거든요, 아직도. 이제 큰 CPU를 웨이퍼에서 최신 공정에서 만들면 문제가, 자, 예를 들어서 TSMC에서 3나노에서, 그냥 예입니다. 정확한 숫자는 몰라요, 저도. 3나노에서 웨이퍼 하나 만들면은 거기 디펙트가, 이슈가 10개 있다고 쳐봐요. 10개. 근데 예를 들어서 핸드폰 SoC를 그 웨이퍼에서 100개를 만들어낼 수 있다고 해봐. 그럼 100개 중에 10개가 이슈가 있는 거잖아. 그럼 100개 중에서 10개 버려도 90개가 남는데, 뭐 같은 웨이퍼에서 3나노 공정에서 이제 CPU를 만든다고 해봐. 그러면은 CPU, 데스크탑 CPU는 더 크니까, 뭐 예를 들어서 뭐 50개 만들 수 있다고 해봐. 그럼 50개에서 10개 버리면은 40개 남는 거예요. 그러면 디펙트 레이트가 10%에서 20%로 치솟는 거죠. 그러면은 이제 그 가격은 고스란히 사용자들, 최종 사용자들, 저희들한테 넘어오는 거고, 더 비싸지고. 그래서 꼭 최신 공정이라고 좋진 않아요. 물론 이제 디펙트가 뭐 2개가 칩 하나에 있을 수도 있다고 쳐요. 같은 칩에. 그래도 그렇게 큰 차이는 없을 거란 말이지. 더 중요한 거는 칩의 사이즈. 칩이 사이즈가 작을수록 이제 최신 공정에 더 알맞다는 말이죠. 불량률, 그래, 불량률. 불량 숫자는 똑같아도 퍼센티지, 확률이 아니고 퍼센티지는 올라간다. I guess they're trying to do nothing and win strat. No, they definitely did put in engineering work into Zen 5. It's just sad that it doesn't pay out. And it's just sad that AMD marketing was horrible. 그래서 PCB에 유리 적층을 쓰는 것 같더라고요. 그래서 요즘 여러 패키징 다양하게 만들긴 하는데, 뭐 인텔의 포베러스든지 AMD의 치플렛이든지, 그래도 여전히 최신 공정 쓰기는 쉽지 않다. 그리고 앞서 말한, 물론 애플이랑 애플이랑 엔비디아가 많이 사용하기도 하니까 돈을 더 주고. 어쨌든 오늘 젠5는 여기까지 얘기하겠습니다. 젠5 5%, 젠 5%입니다. Efficiency 효율 5% 올라가고, 게이밍 5% 올라가고. 오카베님리 어서오세요. 방종할 건데 딱 오시네. 젠 5가 아닌 젠 5%. 자, 젠 5 사지 마시고, 일단은 사지 마시고, 나중에 세일할 때 한 30% 40% 이상 세일하면 그때 다시 한번 가격을 7000 시리즈랑 비교해보시고 성능 가격 비교해보시고 그때 고민해보세요. 지금은 젠5 건드리지 말기. So don't touch Zen 5, wait until they're on 30-40% discount and then you can start comparing to Zen 7000 again. Ryzen 7000. Anyway, I'm going. I'll see you next stream, which is tomorrow. Armored Core collab stream. 내일 아머드 코어 합방 있으니까 그때 놀러 오시고 오늘은 방종하도록 하겠습니다. 라이너스 리바. See if anyone's streaming on Twitch. 바리바리바. 오카베리입니다. 아르비소 사파리바 잠수방님입니다. See you tomorrow. 내일 뵙도록 하겠습니다.